So let's get back to modifying the Simscape model that we have now, so that instead of a DC motor, it will now have a stepper motor. So you will see the beauty of using Simscape, and that is we can make the modification simply by removing the type of motor and replacing it with a new one. I'll just keep it. So I'm bringing in a stepper motor. So the options that I have are the bipolar and unipolar. I hope you know what the difference is. So in a unipolar one, in addition to the 4 tapping points, you have a mid tapping point for a winding as well. So it kind of complicates the control mechanism, and so to keep things single, I'm using the 4-port bipolar motor. So that's not what I needed. Right. So there are 2 stepper motor blocks available. One from the electrical sub-library within the main library, and another from the specialized power systems one. Since all the electrical blocks I have used in previous study as well are from the electrical sub-library, I'll be using uh, the stepper motor from the same sub-library as well. Right, so that's it. So we have the mechanical side, one for the case and one for the shaft, and the 4 ports you see in a regular stepper motor, or regular bipolar stepper motor. Just need to make the connections as was done in the PMB-DC case, and that's good to go. Notice that I didn't make any change other than the stepper motor. Everything, I didn't touch anything else. These were touched. I'll break this connection for the sake of clarity. And as you know, unlike a PMB-DC motor, we can simply connect a constant voltage power supply to the stepper motor and expect it to rotate. We should be providing pulses, and that is done via stepper motor driver. That's one for a unipolar version as well. If you were to use a unipolar, use that, but in this case, we're using the first option. I hope either in the industry or when doing hobby projects that you have wired the stepper motor to a driver, and if not, that's kind of easy to explain. In a stepper motor driver, the windings or the ports which for the ports to which the windings are connected are labeled as A plus, A minus, B plus and B minus. And on a stepper motor, through a simple exercise using a multimeter or even without a multimeter, you can figure out the terminals for separate windings. And once you have figured them out, you just need to connect them. While on the stepper motor driver side, in the physical world, you may see the markings A plus and B plus. The stepper motor, you won't see the markings for and the windings won't be named A and B. So either it's fine if you connect the A and B windings, so the A marked ports to the B marked windings of the stepper motor, and the in that manner, or if you connect A's together. So, and even if you connect the pluses and minuses together, then that's kind of fine as well, as long as if you connect the pluses of one winding, the others for the other windings as well, that same convention has to be followed. Well, those are the possibilities in the physical world, but to keep things clear, we'll follow the convention of connecting the A pluses and A minuses together, and the negative terminals will be connected to ground. So we are yet to parameterize the stepper motor and a driver. We'll keep that towards the end. Now, in addition to the stepper motor driver, the driver requires a source for the pulse pattern. And upon receiving the pulse pattern, based on the pulse pattern, the driver will power the windings in the required manner for the motor to rotate. So what we'll be using to provide the pulse pattern is something called a PWM block. Since I know what its real name is, it's actually controlled PWM voltage. I'll bring that in. It's from the electrical. It can be found in the both electrical and circuit sub libraries. And with regards to the connection, it's kind of not clear with the markings that you see on the blocks with regards to what you have to connect. I see two ref markings on ref ports on both blocks, so there's a high chance that I have to connect these two together. But to make it sure, I'll double click on the blocks and see what's suggested by MATLAB. Well, it says that the driver initiates a step each time the enable port voltage rises beyond the enable threshold voltage. With regards to REV, I think that stands as an acronym for reverse. If the revert post REV voltage is less than or equal to the reverse threshold voltage, then pulse A leads pulse B by 90 degrees. Based on the construction of the stepper motor, when this kind of phase difference occurs, the rotation would reverse. So REV port is for reverse, and if we were to keep it beyond the below threshold voltage, that means no reverse would occur. That means motor would rotate with a direction, positive direction of C to R. Right. With regards to REF, I'm not going to look for it in the description, since I'm kind of sure that REF stands for reference. So I'm connecting these two together and connecting it to the ground as well. If you won't really make it sure, then I suggest you right click on it and go to the head and make sure what it needs to be connected to by yourself. Right, it's input floating reference voltage, and the enable is the port in the motor driver block which receives the pulse pattern, and in the controlled PWM voltage block, PWM is what outputs the pulse pattern, and we connect those two together. Right, and there's something else you need to do. You can right, let's read the description first. So this control PWM voltage can be set into two configurations. One is electrical input ports and another is for PS inputs. If we select the PS inputs, there's only one input port and it requires a signal, perhaps I think a Simulink signal. Read about that in the documentation. I have done so. So yes, U is a signal. U requires a Simulink signal, and upon reaching the signal takes in the signal for the duty cycle, and we can specify that as a constant or it can be a function of some sorts as well. You can provide the duty cycle as a Simulink signal if we use the block choice of PS inputs. But if we were to use the electrical input ports block choice, then the duty cycle would have to be specified as a voltage. And upon reading the description or upon reading the